So I showed the alkali metals reacting. I want to show the halogens reacting. What does volatile mean? If something is volatile, what does that mean? Nope. Nope. So a lot of explosive. There you go. So water is volatile, but not very much. Water evaporates. Gasoline. Gasoline produces gasoline vapor quite readily, which means you can take a fire and actually ignite the gasoline vapors before you actually put it in the liquid. Actually, that's the thing that actually burns is the vapors and not the gasoline. Not as a liquid. If you were to actually put a match and drop it in, don't ever try this, drop it in the gasoline pump system. If you open it up and drop a match in there, there's the entire inside of it has almost no oxygen in it. It's almost all gasoline vapors because gasoline is volatile. You need the right mixture. So, bromine, is a liquid or gas? It's liquid. If we look at this tube right here, this is bromine. You can notice how volatile it is. And down at the bottom is a very dark red liquid, but it's producing a lot of gas vapors because it's volatile. And the bottom of this is a solid. That solid is iodine. Iodine is also volatile. It produces a lot of vapors. Have y'all heard that mercury is toxic? So, you should never try this because it's extremely toxic. You can touch and play with it. It won't do you. And someone drank an entire tube of it and it didn't do anything to them. I have to take that back. It did something, but it wasn't toxic to them. Their entire lungs got filled with mercury, their blood system, but they survived. That's because the danger of it is the vapors that come off of it. You should never, ever, ever take a vial of mercury and smell it. That will kill you or severely hurt you. That's because mercury is very slightly volatile, meaning it produces vapors. And it's those vapors that actually hurt you. It doesn't have a smell. Yeah, they tried to commit suicide. It was intentional that they thought, oh, well, mercury's toxic, so if I drink this, I'll die. Anyway, here is fluorine, chlorine, bromine, and iodine.
Here are the four halogen elements: fluorine, chlorine, bromine, and iodine. Fluorine on the left is almost colorless. Next comes chlorine, which is greenish yellow. Fluorine and chlorine are both gases at room temperature, but bromine is a liquid and iodine is a solid. Even so, they're both quite volatile. You can see the colored vapors, orange-red above the liquid bromine and purple above the solid.
I will mention there's very, very mild profanity in this. This is from a college level.
Solid iodine. Whether solid, liquid or gas, the halogen elements consist of diatomic molecules, F2, Cl2, Br2, and I2. Fluorine reacts often ferociously with almost everything else. A stream of fluorine instantly sets iron wool on fire, and it does the same thing to charcoal. Now let's see the reaction with hydrogen. There's hydrogen in the balloon. A jet of fluorine gas pierces the balloon and explodes with the hydrogen inside. Let's see it again in slow motion. Now you can see the fireball more clearly. Now the reaction between hydrogen and chlorine. I light the hydrogen at the jet and lower it into a jar of chlorine. The hydrogen carries on burning, but with a pale blue flame. When the halogens react with hydrogen, the hydrogen halides are produced: HF, HCl, HBr, and HI. In each compound, the halogen has a valency of 1. All four compounds are gases. They're also very soluble in water. Here's water swallowing a jar of hydrogen chloride. Now let's see how the halogens react with aluminium. When aluminium powder meets fluorine gas, the reaction's over in a flash. To get chlorine to react with aluminium, I'll heat some foil in a stream of the gas. The white fumes are aluminium trichloride. With bromine, I just drop aluminium foil into the liquid. There's a short delay, but normal service is soon resumed. Once the reaction gets going, it quickly takes on the appearance of the pit of hell. As with the chlorine reaction, there's white smoke. That's aluminium tribromide.
Very toxic. It kills everyone in the building.
The reaction with iodine is just as spectacular. A little warming helps to get things moving, but once the reaction's off, it needs no further assistance. The products of all four of these reactions are white solids, and they're all trihalides. AlF3, AlCl3, AlBr3, and AlI3. Now aluminium is a trivalent element, so in these compounds the halogens are all showing a valency of 1. That valency of 1 is also satisfied when the halogen atoms bind to one another in the diatomic molecules with which I started this sequence.
When it says valency of 1, it means that it's gaining 1 electron because it has 7. Not that they have 1 electron.
You know, I feel like they just slide to the side and just a bunch of open tabs.
It's because on this laptop, I shall show you.
Whoa, what?
So this is the screen I see. I put it down. So just to illustrate to you guys, this screen right here is the mirror image of the TV, which means on my tiny little monitor, is taken up by the bottom bar, the top bar, and black side. So I cannot really see the TV screen too well. Our recording software, and of course, since it's taking a picture of the TV screen, it shows the image, and then it shows the image of it taking an image of this, then I'll have the image of itself.
I watched the video last night. The flash yesterday. What's my
So let's play Kahoot. Hope everyone is signed in at this point.
Hey, did you record the day that he was like?
I recorded some period and stuff.
Ah, dang. Yeah, in the background. Maybe it's meant to be like.
I'll quit. Or I'll write you up and send you there as well. We might not have time to finish this because there's like 50 questions. Some of them you guys will not know. But I left them in there because you should be able to figure them out.
That's my name.
Please type an appropriate name for yourself. Otherwise, I'm going to remove it. Who am I missing? Thomas, where are you?
Right. That's my name. I think we're also missing my name's Thomas. Right. You should have put kind of wrong.
Huh. Columns are called
I don't know this one. I got it.
It's called groups. Only 2 people got right.
I got it right. Yes, sir.
Rows are called periods.
Oh, now I'm 6. I hear right. All I hear is, oh, rows are called rows. I'm like, oh, quick road.
Group 1 is called
Look at my name.
what group are known as the noble gases? And these should be A's on them. 8A, 7A, 2A, 1A. Alright, they're in 8A or group 18. Group 2 is called Group 7A is called
I know there's no guy. I can't even tell.
the halogens. The majority of the elements in the periodic table are metals. Which of the following are metalloids? I didn't check to see if this is right. I imported this one. Okay, good. It does accept both answers. Silicon and germanium are both metalloids. Which of the following are liquid at room temperature? This one I'm sure that counts both of them.
What's AG?
Mercury and bromine. Group number is equal to valence electrons. How many electrons they have on the outer shell or energy level? Period number is equal to Energy levels. How many orbits or circles around the atom?
26,200,000.
Which of the following is not a property of metal? Again, choose the best answer.
No, I got it wrong. I told you I chose diamond.
So, ductile is the ability to stretch in the wire. Metals are very good at being stretched into a wire. Malleable is a very metallic characteristic, along as conducting heat and electricity. The fact you're a solid doesn't really mean you're a metal or not. It is true that almost all the metals are solid, but out of the choices, that's the least metallic thing about them, because we have carbon, we have iodine, and these are not metallic. So you have to choose the best answer. So if it's above its melting point, it's above the melting point but below the boiling point. So liquid. If it's above the melting point and below the boiling point, it's a liquid. If a substance that temperature is below its melting point, it's a solid. Group 1 elements react by This is one I haven't really taught yet. So I said, and keep your mask on, Cody. I said that everything wants to have a full outer shell. If you have only one electron, you want to just get rid of the electron so that your next shell is full. So we fill up the shells one shell at a time before we move on to the next one. So all the inner shells are completely full, and it's only the outer shell is partially full. And if you only have one electron on it, you want to get rid of it. The ones on the left side of the periodic table want to get rid of those electrons. Things like fluorine will have 7, that gets full when it has 8. So fluorine will want to gain 1 electron, while oxygen will want to gain 2, and magnesium will want to lose its 2. Which is the most reactive metal? I might want to have y'all's periodic tables up. Cesium, as you go down the list, you get more reactive. If you're on the left-hand side of the periodic table, that's where all the metals are. So when we watched the fluorine video, which was more reactive? Fluorine. So it's the opposite on the right-hand side. You're more reactive as you go up. As you move down group 1, alkali metals are reactive. The reactivity is stop blurting out answers. I didn't say correct answers nor wrong answers. I just said answers. It increases as you go down the first group. The reactivity of group 1 metals increases down because why? Their 1 electron is closer to the nucleus and easier to remove. Their electron is further away. They only have one lone electron. The only way to gain. So the reason why, as you go down the group, so elements only react by their outer electron, their valence electrons. That's how chemistry. Keep your mask on, Cody. So the outer electrons, the valence electrons, tell you how you're going to react. As you go down the group, and add new orbits, more energy levels, that makes the atoms bigger. And because the orbits are so far away, it can't hold on to that one electron as easy. So it's much easier for cesium to lose that one electron than lithium. Lithium's electron or orbit or energy level is really close to the nucleus. They're more strongly. But this is the opposite on the right hand. On the right hand side, like looking at fluorine, fluorine really wants an additional electron so it can have 8. And because fluorine's energy level is so close to the nucleus, it'll easily grab it. So as you move down the group, reactivity is 7A. What happens? The reactivity does. It decreases. That's the video we shown. Fluorine has the highest reactivity. As you go down, the orbits are farther away, so they can't gain electrons as easy. So why does, as you go down, it decreases? It's harder to gain an electron because it's farther away from the nucleus. I basically just explained it. Again, some of these questions I haven't really gone over yet. Which of the following is not an indicator of a chemical reaction? Changing from solid to liquid is a physical change, not a chemical change. Group 2 metals react by very good, y'all are learning. So group 2 metals all have 2 valence electrons. You have to ask yourself, does it want to gain 6 electrons to get 8, or would it rather just remove those 2 electrons in order to have an outer shell that's full? It would want to get rid of that whole outer shell, and so the inner ones are the full ones. How are elements in the periodic table arranged? I have no clue what this is. I'm sorry. Just leave it blank or take a guess. This is obviously.
I just thought about the alkaline metal.
Yeah, I don't know what happened with that one. I must have copied and pasted the wrong answer choices. Hopefully, that's the only wrong one. Groups on the periodic table are arranged.
Oh no, man. Gosh.
Vertically.
I'm good.
What accurately describes nonmetals? So they're poor conductors of electricity.
I'm not getting that wrong. Hey,
Which of these groups on the periodic table is most reactive?
I know it, y'all don't. Dang it, you're wrong. I got the outline. That's it.
Remember, back then they studied things on reactivity and they couldn't even find the rare earths because they didn't react too well, or they were so similar. Which group of elements is unreactive? Which properties most accurately describe the element silicon? So they're not highly conductive, and they're not poor conductors. They're weak conductors, and it's also solid. Each horizontal row on the periodic table is called a period. How many periods are on the periodic table? So there's 18 groups, but there's only seven periods. Which group includes some of the most familiar elements like nickel, iron, and cobalt? Intertransition metals is the alternate name for rare earth metals. That's the 2 rows down below. So transition metals are the middle ones. Elements with an atomic number higher than blank are not found naturally. What is 92? What is element 92? Uranium. Uranium is the heaviest element that occurs naturally. Again, there's a few of them that you can figure out. For example, I said in class, I'm pretty sure I said it in class, plutonium, for example, is man-made. And you should probably have uranium-92 memorized. Which group of elements on the periodic table are all gases at room temperature? Remember, iodine, which is a halogen, is solid. Bromine is a liquid halogen. But when it's asking which one are gases, that's obviously going to be the noble gases. Which pair of elements would have similar properties due to their position on the periodic table? You should just be able to look at the names and tell we're very similar. Copper and gold. Bronze is mostly copper. So you can think of the trophies we get. We get a gold trophy, a silver trophy, and a bronze trophy. Bronze is mostly copper. They're all in the precious metal section, and they all are. You might have heard of gold-plated wires because of how well they conduct electricity. What Russian chemist first began organizing the elements based on their atomic masses?
It's got to be Niels Bohr.
The number of protons found in the nucleus of atom is known as the atomic number. The periodic table is just a list of elements. It contains no other useful information.
I chose two.
The arrangement of the atoms themselves is information. It tells you just having the elements arranged in that way. Which of the following cannot be found on the periodic table of elements? Chemical name, the atomic number, who discovered it. Most periodic tables don't have whether or not it's a metal, non-metal, or a metalloid, but you should be able to draw the staircase and figure it out. Based on its arrangement, you should be able to look at what's the metals and not metals, just based on the arrangement of the periodic table. But who discovered it is not on there. If the atomic number of carbon is 6, how many protons does it have in its nucleus? So it has 4 valence and 6 protons, and the most common isotope of carbon also has 6 neutrons. Has a mass of 12.01. Every chemical's name originates from a Latin term. False! Not every name originates from Latin. Some come from Greek.
I got it.
Which of the following would not be a source of an element's chemical name? Have you ever heard of francium? Americum? Americesium, I mean, or something like that? Ever heard of Einsteinium? Einsteinium is named after Einstein. So some of the chemicals are named after scientists. Some of them are named after towns and countries and continents. But Roman numerals is not used in naming the actual elements. How is average atomic mass calculated? Neutrons, electrons, isotopes, or ions. by averaging the isotopes. So the mass comes from the protons and neutrons. The electrons have so small a mass they almost weigh nothing. What are the three major categories used to classify elements on the periodic table? Again, choose the best answer. Yeah, best answer. Sections isn't used. There's no such thing as sections. So that rules out blue. Solid, liquid, and gas isn't that useful. But metals, non-metals, and metalloids is the best answer. On the periodic table, what is used to help distinguish between metals and non-metals? The zigzag line. The staircase. Also known as the zigzag line. What two elements are liquid at room temperature and standard pressure? Yeah, some of these have been repeats. Bromine and mercury. Elements that have the same number of valence electrons are found in the same group. Mendeleev organized the groups of elements with similar properties into So the groups on Mendelev's table was rows, whereas groups on the modern one is columns. Last question. Mendeleev didn't know about which group of elements? The noble gases.
They're still accurate, but you got hit the second hit, and you got hit back on the second, and you got power to be the whole time.
So let's go over the difficult ones. The reactivity of elements in group 7A decreases because the electrons are further away from the nucleus, the energy level. How is the average atomic mass calculated? By the averaging the mass of each isotope, commonly found isotope. Uranium is the last element that is found naturally. Did I tell y'all how one way we can find aliens is? Yes. So if we look up into the stars, And each element, whenever an electron falls into a lower orbital, it emits light, and it emits an exact frequency of light. If we were to shine up, or we were to look at the stars and see plutonium in one of the stars, we know without a doubt that the only possible way that could have happened is if an advanced civilization capable of producing that element put it into their own star. It has been talked about doping our star with plutonium by sending a nuclear bomb to it, and indicating to everyone that can look at our sun that we have advanced life around it. One of the reasons why there's a few reasons why we haven't done it. Do y'all know what the major reason is? No, it's the fact that carrying a nuclear weapon in outer space. Have y'all ever seen the rocket launches and how many of them have failed? We don't want a highly radioactive container to blow up in Earth's atmosphere and spread that radiation back down on the ground. That's one of the primary reasons we don't launch them up. Second reason is, should we announce to the universe that we have life? It doesn't really matter. We're constantly broadcasting radio waves anyway. But anyone around us that can pick up the radio waves would be able to tell life surround us anyway. So what is the most reactive metal? That is cesium. What is the most reactive element in general? Most reactive element in general. It's between cesium and fluorine, but most people would agree fluorine is more reactive. Columns are called groups. Metals have the property of, I can't read those choices, ductile, malleable, and can conduct electricity. As you move down the group, reactivity decreases. As you move down the group of 1A metals, it increases because the electrons are farther away and easier to be removed. So it decreases as you go down. We have. It's actually controversial. I'll pull it up. Be mature. The space card sent into space. Let me stop recording.